Hello everyone, I'm Shailja Tripathi and today we'll be discussing electric potential and potential difference. So let's get started. To understand this concept, we'll use an analogy. See, we have to study current, which is flow of electrons. And in a metallic wire, the electrons won't flow itself. See, if there is a metallic wire lying and it has free electrons. See, metals have characteristic that they have free electrons. So these electrons won't flow itself. It will need a push or a force is needed to move these electrons. And when these electrons start moving, we say current or electricity is generated. So see, to understand this concept, we'll use the analogy that air flows because of difference in pressure. Similarly, water flows because of difference in height. That is, water will flow from higher side towards the lower side. That is, there will be a difference in gravitational potential energy. So similarly, in a metallic wire, electrons are present but they won't flow until and unless some difference is created. That is, difference of electrons. That is, at one point there are excess of electrons and at another point there is deficiency of electrons or electrons are deficit. So if this difference is created, the charges will start flowing or the electrons will start flowing. And this difference is called this difference is due to electric pressure, which is also called electric potential. So when there is difference in electric potential, we say a potential difference is created. So we must understand what is this electric pressure or electric potential. See, in our book, for flow of charges in a conducting metallic wire, gravity of course has no role to play. That electrons do not flow due to gravity, just like water is flowing. So it is not the case in metallic conductors. The electrons move only if there is difference of electric pressure called the potential difference. This electric pressure is also called electric potential or voltage. See, this difference may be produced by battery consisting of one or more cells. So, if this is a metallic wire, see, and metallic wire will have free electrons. This is the characteristic of metallic wire. See, these electrons are present but they are not flowing. That is, there is no current. But if this point A and this is B, if this is connected to a, see, this is positive end, this is the negative end. Positive end is called anode, negative end is called cathode. And negative end is has excess of electrons. So this will have excess of electrons and anode has deficit electrons, that is no electrons or very less electrons. So here we have deficit electrons. So electrons are excess at cathode. So these electrons, and here there is deficiency, so this difference is created and electrons will start moving in this direction, that is from excess towards where there is deficiency, that is it will be attracted towards the positive end. So electrons will start moving in the conductor. And we know that current flows in opposite direction to the flow of electrons. So current starts flowing from positive to negative end. So the cell or battery is generating a difference between these 2 points, and the difference is that at one point we have excess of electrons and at other point we have deficiency of electrons, and this difference makes the electrons flow. Okay, see, positive end of the battery is said to be at higher voltage. Higher voltage. What is this voltage? I'll explain it. And the negative cathode or the negative terminal is said to be at lower voltage. Lower voltage. That is lower electric potential or lower electric pressure. And this difference is created because of the chemical energy or the chemical reaction that is going inside the battery. So this chemical energy is getting converted into electrical energy. Okay, so we can say current flows from higher voltage towards the lower voltage. Okay, and now we'll define what is voltage. See, if this is a metallic wire, see here at point A we represent voltage as VA and at point B as VB. Now what is this voltage? Voltage is said to be amount of work done in bringing a unit positive charge from infinity to that point. See, voltage or electric potential represented by V is defined as amount of work done. It is defined as amount of work done in bringing unit positive charge. Unit means 1. Unit positive charge from infinity to that point. See, why work is being done. Okay, we'll understand this in this manner. See, to understand this, we must see if there are two charges, positive and negative opposite charges, and let's say we have similar charges also. Or the situation is we have both negative charges. So if there are two opposite charges, they will automatically attract each other. That means there is a force of attraction between the charges. And in this case, charges will repel each other. That is again there is repulsive force. That is force exists between charges, either attractive or repulsive. So let's think of a situation that there is force of attraction between the charges. Now what you do, keep this charge at some point and we start taking this positive charge away from this charge, negative charge. Let's say we have taken this charge to a point where both the charges do not experience any force, that is there is no attractive force between them. So what will happen, there is no force between these charges at this situation when one of the positive charge is kept at a far away distance And let's assume that this distance is infinity. It can be any point where the force is 0. See, now if we need to bring this charge near this negative charge, so what we are doing? We have to bring this charge closer, closer, closer. A point will come, then it will automatically be attracted. At that point, we are not doing any work. It is doing work itself. But some work is done to bring the charge to, to some distance, or some work is being done to bring this charge, so that again a force is created. So this is called voltage, that is amount of work done to bring a unit positive charge from infinity to a given point. So the amount of work that is done is called voltage. And you must have studied in your class 9 that amount of work done is directly related to energy. The energy and work have same units. See, both are expressed in joules. So energy is nothing but work. So the amount of work that is being done, that only means that some energy is being used up to do this work. That is, work and energy are synonymous terms that both have same unit, that is joule. Okay, so voltage at point B is the amount of work done to bring a unit positive charge from infinity to that point. And again, voltage at B can be defined in the similar manner. Again, it is again the amount of work that is done to bring a unit positive charge from infinity to this point. So this is the definition of voltage, that is some work is done. So what is potential difference? So if we assume that A is at higher potential than B, so if we assume that voltage at point A is higher than B, then current will flow from A to B, and we can easily find the difference of the potential. Again, difference of the potential will be, now if we are finding the difference in potential between point A and B, then the definition will be amount of work done to bring charge, a unit charge from point A to point B. So it is the amount of work done to bring the unit charge from point A to point B. So unit of voltage or electric potential is volt, represented by V. Work is represented, its unit is joule, and charge is coulomb. So 1 volt, if you need to define 1 volt, it is the amount of work done, or when 1 coulomb charge is moved from one point to another, and the amount of work done is 1 joule. In moving 1 coulomb charge, we say it is 1 volt. Potential difference is 1 volt. So potential difference of 1 volt is generated when a unit charge, that is charge of 1 coulomb, is moved from point A to point B and work done is 1 joule. So here see the potential difference, it is mentioned. The potential difference between 2 points is work done upon charge. So V is equal to W upon Q. And the SI unit is volt, named after Alessandro Volta, an Italian physicist. So volt is actually derived from the surname of this scientist. And 1 volt, definition of 1 volt is also given, is the potential difference between the 2 points in a current carrying conductor. when 1 joule of work is done to move a charge of 1 coulomb from one point to another. So this is, if you remember this formula, you can easily form the definition of 1 volt. That is, it is 1 joule upon 1 coulomb. See, potential difference is measured by an instrument called voltmeter, and voltmeter is always connected in parallel across the points between which potential difference is to be measured. So what does this mean? See, if we have a bulb here connected to a cell and we want to find the potential difference, across point A and B. Across means between 2 points A and B. So where we will place this instrument? Voltmeter. See, voltmeter will be placed, that is, we have to find, let's assume, potential difference across these 2 points X and Y. So we'll make an arrangement and place the voltmeter in this manner. That is, it will be parallel to the bulb. So if we need to measure the potential difference across this bulb, we'll place the voltmeter in this manner. So this is voltmeter. And if we have to know amount of current that is flowing in this circuit, we'll place ammeter, and we know ammeter is always placed in series. Series means end-to-end connection. That is, this is, if it is representing a bulb, or let me make it in this fashion. This is a bulb and I need to know how much current is flowing. So ammeter will be placed in series, that is, end-to-end connection will be made. Then after the bulb, you will place an ammeter. But in this case, this series and parallel connection will become more clear when we'll talk about resistors. So for the time being, we'll just understand that series is end-to-end connection and parallel means we have to place it in a manner that the voltmeter is placed across or between those 2 points. See, between the points. See, these are the 2 points, so it will be placed between these points. This is a parallel connection. Now let's see these questions. See, how much work is done in moving a charge of 2 coulombs across 2 points having a potential difference of 12 volt. So we are given charge Q is equal to 2 coulombs and potential difference V is given 12 volt. So how much work is done? So we have studied just now that potential difference or voltages, amount of work done in moving the charge. So you can write V into Q is equal to work done, that is 12 into 2, that is 24 joule work will be done. The answer is 24 joules. Now let's come to this in-text question. See, the first question says, name a device that helps to maintain potential difference across a conductor. So the device is cell or a battery. What is meant by saying that potential difference between the 2 points is 1 volt? We just discussed it. When 1 coulomb charge is moved from one point to another and work done is 1 joule, we say potential difference between the 2 points is 1 volt. So here actually you have to give the definition of 1 volt. Now, how much energy is given to each coulomb of charge passing through 6-volt battery? See, here we are given each charge, each coulomb of charge. Each coulomb of charge means 1 coulomb charge. V is given, value of V is 6 volt, and we have to find energy. Okay, how much energy is given? Energy. So do not get confused, because just now I explained that energy and work are synonymous terms in physics. So energy is nothing but work done. Okay, how much energy will be used up? That will be equivalent to how much work is done or how much work is obtained. So using the formula, V is equal to work upon Q. So find V into Q will give you work or energy. So V is 6, Q is 1, so we get 6 joules. So how much energy is given to each coulomb of charge? That is 6 joule is given to each coulomb of charge. This much energy is given. Okay. Hope you understood this topic well. Please like, share and subscribe. Give your comments in the comment box and let me know if the topic is clear to you. Thank you so much.